Alright, welcome back. In our previous video, we were introduced to the cosine ratio, and now we're going to use the cosine ratio to find side lengths of a triangle. Okay, so we want to use the cosine ratio to approximate the width of this basketball court. So the width is right here, so that's y feet. In a previous video, we used the sine ratio, and we learned that this length right here, this hypotenuse, is 106.46 feet. So we're now going to use cosine to find the width. Okay, so here's our angle measure, and y is the adjacent leg. And 106.46 is the hypotenuse. Now we had that word SOHCAHTOA, S-O-H-C-A-H-T-O-A, and here we're dealing with the adjacent leg and the hypotenuse. Adjacent leg and hypotenuse is cosine. So we are using cosine here. So cosine 62 degrees is to 1, as the adjacent leg, y, is to the hypotenuse, 106.46. Okay, so when I have a number down here, not a letter, I use my cross products. I have y times 1, which is y, and my other cross product is 106.46 times cosine 62 degrees. Okay, so I have 106.46 times cosine 62, and that is 49.98. Okay, so y is 49.98, so it's right about 50 feet for the width of this basketball court. Okay, now what happens if I don't have a calculator that does cosine? Okay, so you can use an online calculator that has cosine. There's plenty of free calculators online that do that. Or on this chart, cosine 62 is 0.4695. Okay, so if I use 0.4695, I've got 106.46 times 0.4695, and I get 49.98. Okay, now these aren't exactly the same, but they're extremely close. The one that I used cosine in the calculator for, that's a little bit more precise, but they're both very close to each other. Okay, so find the value of x. So I've got an angle right here, and one of my sides right here, that is the adjacent leg. And this over here is the hypotenuse. Adjacent leg and hypotenuse, that's cosine. So we have cosine 37 degrees is to 1, as the adjacent leg is to the hypotenuse. Now here's a case when I've got a variable in the denominator, so what I want to do is use that property of proportions that says I can switch things diagonally and get x is to 1 as 27 is to cosine 37. So we have 27 divided by cosine 37, and we get 33.81. Okay, so next, we've got a railroad crossing arm. It's stuck 35 degrees up, so this has an angle of elevation, which means I've got a horizontal line, and it's opening upward. That's an angle of elevation of 35 degrees. Find the values of x and y. So let's start with x. X is across the triangle from that 35 degree angle, which means it is the opposite leg. And 20 is the hypotenuse. Opposite leg and hypotenuse right here. Opposite leg and hypotenuse. That means we're going to use sine. Sine 35 degrees is to 1, as the opposite leg is to the hypotenuse. And since I have a number down here in the denominator, I'm just going to do cross products. X times 1 equals 20 times sine 35 degrees. So 20 times sine 35 degrees is 11.47. And this has a unit of feet. Now for y is the adjacent leg, so we'll use the adjacent leg and the hypotenuse. Adjacent leg and hypotenuse, that's cosine. So cosine 35 degrees is to 1, as the adjacent leg y is to the hypotenuse 20. So my cross products are y times 1 and 20 times cosine 35 degrees. 20 times cosine 35 is 16.38, and it's in feet. What if the angle of elevation isn't 35 degrees, but now it's 40 degrees? Okay, so we're just going to replace the 35 with 40. So now we have sine 40 degrees is to 1, as the opposite is to the hypotenuse. So my cross products are 1x and 20 times sine 40 degrees. 20 times sine 40 degrees is 12.86 feet. Okay, and then cosine 40 degrees is to 1, as the adjacent y is to the hypotenuse 20, and my cross products are 1 times y and 20 times cosine 40 degrees. 20 times cosine 40 degrees is 15.32 feet.